So my name is Hitesh Bindra. I am an associate professor in School of Nuclear Engineering at Purdue University. And I started my career about 20 years ago as a nuclear power plant engineer. Uh, I call exact title was reactor engineer. In that role, what I started learning was that basically how a nuclear power plant operates, how to put together different components of a nuclear reactor core and the power plant components, and then basically be able to generate electricity. And then I learned after that a lot of things about the vast amount of things that can be done in nuclear engineering as such. So nuclear reactions, which involve subatomic particle interactions with the nucleus of an atom, they basically can generate a lot of energy, but they also have many other applications. So the oldest form of the nuclear reaction that we know are radioactive decay. So where do we use that radioactive decay? X-rays are basically another form of the nuclear interactions. So what we do with nuclear energy or nuclear reactions is not just basically to produce electricity, but also to for X-rays, for medical imaging, for forensics, for maintaining the or for basically exploration activities. So for example, if we have to find some minerals, we find those minerals with the help of the X-rays. We find those minerals with the help of the radiation sources. So there are several the vast amount of applications. And the good news about the careers in nuclear energy and nuclear engineering is that basically almost every country in the world, it has a dedicated government labs, which basically are always continuously hiring people. One of the major challenge that we have right now in US and other parts of the world is that the people who build the infrastructure for the nuclear energy and nuclear engineering research around the world, they have retired. So we need to fill those people with the people with PhD degrees, with master's degree, with bachelor's degree, across the scope, across the scale, we basically need this human involvement, personal involvement, and where do you actually start with? So there is one way of basically nowadays, of course, the universities and the colleges and the atomic energy bodies of the government around the world, they basically they have developed high school to diploma programs for the initial introduction for the nuclear engineering. International Atomic Energy Agency, it has tutorials for basically from a layman to a good expertise. They have this material available on the IAEA website, which are free for all, available for all. That can be used to provide initial introduction. Then obviously in the case of the college education, 4-year degrees, nuclear engineering program, there are several schools in the United States which basically offer nuclear engineering bachelor's degree. And then also basically there are several programs around the United States and other parts of the world which basically offer nuclear engineering minor education. So to summarize again, nuclear engineering is basically only a 80-year-old field. It's one of the very recent engineering fields. And we have barely scratched the nuclear reactions. There is a lot to be uncovered. It's not just nuclear energy. It is basically one type of reaction which goes into nuclear energy. Imagine if we have improved understanding and if we know how to engineer that physics of nuclear reactions, how many other applications can be. And many applications such as being medical physicist or geologist, where nuclear energy is used or nuclear reactions are used, are overlooked, and there are those opportunities waiting for you.